Assalamualaikum warahmatullahi wabarakatuh and hi everybody. Welcome to PMC 500 Statistical Reasoning in Education. So today what we're going to learn is on analysis of variance, or the acronym for analysis of variance is ANOVA. I am Dr. Nur Asliza Ishaq, or you can call me Dr. Ija. So the objective of our lecture today is for you or for us to discuss the understanding of one-way ANOVA, which referring to the mean difference for K sample. So what is ANOVA? ANOVA stands for analysis of variance. So the purpose of we analyze the data using ANOVA is to compare the population means between more than two groups by using variances. If you recall back in the previous lecture, which is independent sample t-test, it involved one independent variables and one dependent variables. However, the maximum number of category or level for the independent variables in independent sample t-test would be 2. So what happens when you have more than 2 categories for your independent variables? You cannot run independent sample t-test, but instead you will use one-way ANOVA by using variances. So actually there are two types of ANOVA, which the first one would be one-way ANOVA and the second one would be two-way ANOVA. So what is one-way ANOVA and what is two-way ANOVA? So in one-way ANOVA, it tests the effect of one independent variable on a dependent variable. So meaning that your data or your research which consists of one independent variables and one dependent variables. But in two-way ANOVA, it tests the effect of two independent variables on a dependent variable. So meaning that in two-way ANOVA, you will test two independent variables, but only have one dependent variable. So that's the difference between one-way ANOVA and two-way ANOVA. So in one-way ANOVA, it only involves one independent variable, but in two-way ANOVA, it involves two independent variables. So, of course, when you want to do an inferential statistics, there are several assumptions that you need to fulfill. Same goes with assumptions for ANOVA. In ANOVA, the assumptions that you need to fulfill would be your data must be independent observation. And of course, first things that you need to do first, the data that you collect or the sample that you choose must be randomly selected, and then independent observation, and you must have an homogeneous variances. What does it mean by homogeneous variances? It means that the data would be having the same population variance for each group. And of course, in most of the assumptions for inferential statistics, you need to make sure that the data that you collected would be normally distributed. So here it means that larger samples required to produce relatively valid result if this assumption is violated. So if you have a large sample, there's a probability that you can violate the assumptions for normally distribution. But if your data is not large, it means that your data should be normally distributed, where you can test using numbers or you can test using graph. So now let us look at what or how can we do a one-way ANOVA. So one-way ANOVA, the one in one way refers to the one independent variable that being analyzed, just like what I have discussed or I have explained before. Okay, so the objective of one-way ANOVA analysis is to find out if there are any significant differences among 3 or more sample means, which referring to your independent variables. So your independent variable should consist more than 2 sample means, or 3 or more. So the one-way ANOVA is a test of differences in means, 3 or more sample means, that will compare all categories simultaneously. So one-way ANOVA, the functions of ANOVA is to test the mean difference between your sample, where you have more than 3 samples for your independent variables, and this testing will run simultaneously for the 3 samples that you have for your independent variables. Let's look at one example. For example, here, mathematics teachers in a school have devised 3 different methods to teach geometry. they want to find out if this method produced different mean score. So if you look at the example here, okay, you can see that mathematics teachers in the school have devised 3 different methods. So that three different method would refer to the independent variables. One independent variable, which is the teaching method, but having 3 categories under it, which is 3 different methods to teach the geometry. So they want to find out if this method produced different mean scores, or mean scores become the dependent variables. Okay, so we have one IV, one DV, but the one IV having 3 or more categories. So therefore, we can run one-way ANOVA. So the analysis, one-way ANOVA. So the analysis, in one-way ANOVA is called analysis of variance because variability of all observation is an experiment. In an experiment is divided into 2 sources. Okay, so the first one would be the variability between group. So in SPSS is called as between subject factors, where it refers to variations between the distribution of individual groups or level as the values within each group are different. And then we have another one which is variability within each group. In SPSS is known as between subject effect. So it refers to variation caused by differences within individual groups or level, as not all the values within each group are the same. So we have 2 analyses of variance. One is between subject factors, or also known as variability between group, and another one is between subject effect or variability within each group. So in between group, you have 2 different groups, but in within each group is involving one group only. Yeah, it's within individual group. So that's the difference between group and within each group. So I repeat, in between group, the variation is involving individual in different group, but in each group, within each group, it involves within the same group. Yeah. Well, of course, when you want to run an inferential statistics, things that you must to have or must construct would be the hypothesis. Same goes with one-way ANOVA. So you need to develop the hypothesis for one-way ANOVA. So of course, there are 2 types of hypothesis, which are the null hypothesis as well as the alternative hypothesis. So let's look how we can construct a null hypothesis for a one-way ANOVA. So the null hypothesis, all k populations means mu1, mu2, and mu_k are equal, or the way you write it properly would be HO, which is referring to hypothesis null, where mu1 would be the same as mu2, would be the same as whatever number of population means. Yeah. And the alternative hypothesis would be HA, which is the alternative hypothesis. At least one pair of the population means differ. There's another way of we can write the null and the alternative hypothesis for one-way ANOVA in a sentence form. Okay, the first one would be in a symbol form. The second one would be in a sentence form. For the null hypothesis, there is no significant differences among 3 or more sample means. But for the alternative hypothesis, there is a significant differences among 3 or more sample means. So you can write what is your sample means. Yeah, maybe method 1, method 2, and method 3. Okay, for example, right? So this is how we construct a hypothesis for a one-way ANOVA. Now, in one-way ANOVA hypothesis, if the ANOVA test is significant, it indicates that at least 2 of the group have means that are significantly different from each other. So you must remember, in one-way ANOVA, in independent variable, you have 3 or more levels for your independent variable. For example, for mathematics method, you have 3 types of mathematics method. So in this case, in one-way ANOVA hypothesis, if your hypothesis is significant, significant means P is less than 0.05, it shows that at least 2 of the group have mean that are significantly different from each other. Not necessarily have to be all 3, but at least 2 from the 3 would be significant. Yeah, and Therefore, the null hypothesis in ANOVA test is rejected. However, if it does not tell you which of the group are different, so the question is which group means differ from one another. So you need to perform multiple comparison analysis. In next video, I will teach you how you can perform a multiple comparison analysis for one-way ANOVA. So I repeat again, in hypothesis testing, if your p-value is less than 0.05, it shows that your ANOVA test is significant. And this significant value means that at least 2 from the 3 of your levels in your independent variables or 2 from 3 of your groups in the independent variables are significantly different in terms of their mean from each other, and the hypothesis null would be rejected. And to further analyze which group are different, you need to perform a post hoc test or a multiple comparison analysis. Another thing that you should consider when analyze your data using one-way ANOVA is the effect size for ANOVA. So what is an effect size? Effect size, in a nutshell, is a value which you can see how much the independent variables, or IV, has affected the dependent variables. Yeah? Even though it's significant, we must know how or what will be the value. Yeah? Value where you can see how much the independent variable has affected the dependent variables. So in another way, it's called measure of association. So eta squared or partial eta squared is used to measure the effect size for ANOVA. So usually the eta squared ranges from 0 to 1. Yeah? So 0 means no differences in the mean score, while 1 means there is a differences between at least 2 of the means. So the value of 0.01 indicates a small effect size, value of 0.06 indicates a medium effect size, and more than 0.14 indicates that it has a large effect size. So this would be the rules of thumb for measuring the effect size of ANOVA. So in SPSS, for one-way ANOVA, yeah, you can calculate one-way ANOVA in 2 different ways. The first one is through analyze, compare, or the first way is through analyze or compare means or one-way ANOVA. The other one is through analyze general linear model using univariate. So you can choose under the tools menu bar of the SPSS either to run a one-way ANOVA in SPSS using one-way ANOVA itself under compare means, or univariate under general linear models. So one advantage of doing so is that we can estimate effect size from this menu, but we could not from the one-way ANOVA menus. So there's one advantage of using univariate over the one-way ANOVA, because in univariate you can test the effect size, but in one-way ANOVA you cannot test the effect size. So however, you can run analysis of one-way ANOVA in SPSS using these 2 statistics or using these 2 way of analyzing it. But the advantage of using univariate is that you can test the effect size, but you cannot test the effect size when you analyze using a one-way ANOVA under the compare means menu. Okay, now I'm going to teach you how we can run a one-way ANOVA using SPSS. So you need to key in all the data in the SPSS, and after you have keyed in all your data, you go to the menu bar and then click Analyze, choose General Linear Model. Like I say, why I choose General Linear Model under univariate, because you can test the effect size. So you choose General Linear Model and then choose univariate, and then insert the dependent variable into the dependent variable box, and followed by insert the independent variable into the fixed factors box. So choose options, and then drag the word major, from factor and factor interaction into display means for, and underneath it you have a display box where you need to choose descriptive statistic, estimate of effect size, and homogeneity test to test the homogeneity of the variances. And make sure you set the significant level at 0.05 confidence interval. And after you have done that, you just need to click OK. So this is the menu or the way or the step that you can do in calculating one-way ANOVA using SPSS. So this is the menu bar. You go to Analyze, choose General Linear Model, and then choose Univariate. And after in the univariate box, you key in or you transfer your dependent variable into the dependent variables box and the independent variables into the fixed factors box. So in this case, our independent variable is days and the independent variable would be the different majors. Yeah? And make sure your independent variable should have 3 or more levels. And then you need to choose options. And under options, you transfer major under factor and factor interaction into display mean for. And then under display, you need to take or to choose descriptive statistic, estimate of effect size, and homogeneity test. And make sure your confidence interval is at 95% or your significant level is 0.05. And then you click continue and then you click OK. Thank you very much. This is for joining the lecture for the concept of one-way ANOVA.